Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is a reaction to an article published on InfoQ on 8th of July 2024. The article is about architecting software for a greener future. And I've been talking about this for some time that we will need to think sooner or later about building software that is more, let's say, carbon efficient or greener, or however you want to call it. And so I really like that they published this article, and let's go through it and see and comment, react to what it's detailing. First of all, this article, so as I said, the InfoQ, Architecture and Design section, how to architect software for a greener future. The link is in the description below. This was published July 2024, authored by Sarah Bergman, Senior Software Engineer at Microsoft, and reviewed by Almir Vuk, Software Development Engineer and Microsoft MVP. Key takeaways: carbon-aware actions can help you be greener. Machine utilization is vital to carbon efficiency. The cloud can be helpful in architecting software for a greener future, but it is not without action from you. The software will benefit from carbon efficiency. Building green is cheaper, more performant, more secure, and more resilient. And let me just say one thing which is very important. The cloud can be helpful in architecting software for a green future, but it is not without action from you. My feeling is that many companies believe that if they just use the cloud, then those companies will take care of carbon emissions, green energy, whatever, and that's all you need to do. And I don't think that's enough, because in addition to this, at least things that I'm thinking about is you have build processes, you have local servers that you are using, and so on. So the question is, if you take one product that you are developing, how could you make that greener? And take into account the whole chain, not only the deployment and the operations, but also development. Now, I'm not sure if this article is about development or only operations. It seems that it's more focused on operations, and we'll see what are the challenges with operations. That's very interesting as well. In this article, I will share tips, tricks, and advice on architecting software for a greener future. I've been discussing this topic for several years. Previously, I might have started with some NASA data showing global temperature, carbon oxide levels, ocean warming, or methane concentrations to highlight climate issues. However, I'm done discussing the problems. Many others speak on climate change eloquently. Instead, this article will focus on solutions. Assuming you're already aware of the climate change situation, we will move straight to addressing it. Okay, fair enough. Why operational efficiency? Okay, and there's a graph here titled "What Makes Software Green?" And its root is carbon efficiency, emit the least amount of carbon possible. Then on the left, energy efficiency, use the least amount of energy possible. In the middle, hardware efficiency, use the least amount of embodied carbon possible. And third one, on the right, carbon awareness, do more when the electricity is cleaner and do less when the electricity is dirtier. Operational efficiency architecture connects to green software within the broader context of software development, but this is it worth discussing. To answer, we first need to ask, what makes software green? Sustainability is a broad term that involves water and land use, carbon emissions, and building software for green purposes. This article focuses on carbon efficiency, which includes three key aspects: energy efficiency, hardware efficiency, and carbon awareness. Why should you care about operational efficiency? Isn't code efficiency enough? Efficient code is excellent, but rewriting software in highly efficient language like Rust can be time-consuming and may require skills your organization lacks. Platforms and languages should help with code efficiency, but it's not a silver bullet. So that's an interesting thing that she's mentioning, rewriting code in more efficient languages, because this is one sticking point if you want greener energy, greener software, sorry. If you want greener software, you might need to switch to a more efficient language. Although the things that I'm thinking, if you take into account the whole development process, you have a whole bunch of compilation going on with Rust or C++. So even if the operational level is optimized, the question is, how about the development level? And I still haven't got an answer to that. The question is development, is the energy consumed or the carbon emitted through the development process negligible compared to the operational one or not? And should we care about that as well? And this is a question that I still didn't get an answer to. I'm still curious to find out. What about data center efficiency? While hyperscale data centers are more efficient and cloud providers focus on sustainability, cloud users are responsible for sustainability in the cloud. Like driving an efficient car recklessly, inefficient cloud usage still produces emissions. What about greener grids and renewable energy? While the transition to renewables is happening faster than ever, it's not fast enough. Software must operate efficiently in a world with variable electricity supply, making future-proofing essential. And greener hardware. Despite advances, green hardware alone doesn't solve energy problems and cannot meet high-performance requirements. Operational efficiency is worthwhile because it's within your control. You don't need to wait for external developments, you can start today. Small efforts can yield significant benefits, often resulting in cheaper, more performant, and more resilient services. I hope this article convinces you of its importance. So, this is the rub, I think, because many organizations... Okay, this is an extra expense, let's be clear, because taking this into account needs you to make some changes in the operational usage of your systems. And so this is why my feeling is that most companies are counting on cloud providers to create greener data centers. And we know that there's a lot of investment there. I mean, many data centers from Microsoft, from Google, from Amazon, they have their own green energy and all this stuff. And optimized ventilation, well, heat management would be more correct, and so on. So they are definitely doing a job there. My feeling is that it will be fairly difficult to convince organizations to improve on their side. But let's see, because I'm interested in what needs to be done, but I'm also interested in what are the advantages for organizations, because oftentimes when you do these things, they might be more advantageous as well. They might bring in some unexpected benefits. So let's see. Carbon awareness. I mentioned carbon efficiency, an umbrella term meaning to use the least amount of carbon possible. Carbon awareness is one aspect of carbon efficiency. Although it sounds a bit sci-fi, carbon awareness means using electricity when and where it is greener. This approach helps decarbonize the grid immediately by using existing green energy and supports renewable energy producers financially over time. Does this work? Moving all workloads in the world to a place like Norway, which relies on hydropower and is green, sounds attractive. But all the workloads in the world are a lot, and this would overload local data centers. Moving some workloads, however, when logistically and legally makes sense, is a good idea. Carbon awareness is not a silver bullet and must be used correctly to be effective. When appropriately applied, it's a powerful tool for short and long-term benefits without overwhelming specific regions. You can access data on grid greenness through various APIs which provide real-time information and 24-hour forecasts. These APIs are incredibly useful as you won't need to learn all the details about your grid. Just use the API. So this is very interesting. Basically what it means is that you could move your workloads to regions that use green energy and maybe use them, move them during the day. So one possible scenario here would be basically to switch your services to another region based on the peak of green energy available. Of course, this comes with the potential for slower load times. So there's always, there are always trade-offs. When we talk about architecture, there are always trade-offs. And we are kind of new at thinking about trade-offs in terms of carbon emissions and green energy. So it's going to be some interesting times ahead. Carbon efficiency. When it comes to architecting for carbon efficiency, it boils down to machine utilization. Maximize the use of your physical resources. The goal is to extract as much as possible from your hardware. Why? Firstly, efficiently using one server may eliminate the need to buy another. If one server is inefficiently used, you might need another one to handle the workload. Secondly, there's a thing called energy proportionality. The switch-on cost of a server is high. Having an idle server incurs a significant baseline cost. As you add more tasks, energy use increases, but not drastically. The baseline isn't zero, it's quite high. What can you do? Okay, time shift. Firstly, it's a time shift moving to a greener time. You can use burstable or flexible instances to achieve this. It's essentially a sophisticated scheduling problem akin to looking at a forecast to determine when the grid will be greenest, or conversely, how to avoid peak dirty periods. Okay, so this is interesting. Naturally, this strategy should apply primarily to non-demanding workloads. For instance, you can't ask someone to wait 7 hours to buy a ticket because solar panels are active on the grid. However, tasks like app updates can afford to wait. Yeah, so there are specific workloads that you can shift in time. Location shift, basically what we discussed until now. You could move to a different region and so on. And yeah, and they are mentioning this approach isn't always feasible or works well when network costs are low and privacy considerations allow. For example, it is impractical to move our workload across continents due to high network costs and thus high environmental impact. However, shifting to a different region within your country or your cloud provider's network can benefit workloads with few data dependencies. Okay. Now, one thing that I find until now that I would prefer to see less of is this focus, full focus, or there's a bit too much focus on the environmental impact. And I'm not saying that because I don't want to improve the environment. Of course I want to. But the reality is that organizations will not look only at this factor. They will trade it off with other factors. So I would use another argument here. When they say, for example, it's impractical to move a workload across continents due to high network costs, and thus it's basically high costs. It's costly to do that because you have transfer costs between the networks. Yes, there is a high environmental impact because you need to transfer data, and that is also emitting carbon and consuming energy and all this stuff. But I think the argument that would convince organizations is the cost of the transfer. It's not as much or less so the environmental impact. That's my belief. At the end, fortunately or unfortunately, we're discussing about money, and the emissions are kind of intangible. It would be nice to have them as introduced as costs. That's, capitalism in action. Demand shape. The last carbon-aware action is demand shaping, which can seem quite futuristic. Oh, interesting. This involves altering your software's behavior to optimize energy usage, doing more when energy is green and less when it's not. Interesting. There are two approaches to implementing this: making decisions autonomously without user involvement, or offering users an equal low-carbon mode for optional selection. For instance, you can schedule background updates during off-peak energy times without user interventions, or user can opt into eco modes for reduced energy consumption. Yeah, and they already mentioned in the next paragraph, I wanted to say exactly that this is already in your TV or in your consoles. So yeah, your TV has an eco mode. Why not have an eco mode for software that we use? I think that's a good idea. Of course, it might be some additional work from the organizations, but particularly for highly used software built by big technology companies, why not? I'd like to see that. Carbon efficient. Okay. 3 key things that help us carbon efficient: right sizing, fitting your virtual machine or any resource like containers to match its usage on a physical server. Instead of optimistically provisioning a large resource and forgetting about it, right sizing requires thoughtful analysis from the outset. By matching resources to actual needs, you can maximize the use of each physical server, saving energy and reducing embodied carbon over time thanks to energy proportionality. Okay. Right sizing also influences capacity planning in your data center or the cloud. Over provisioning signals the need for more hardware purchases, potentially leading to unnecessary resource use. If everyone adopted right sizing practices, capacity planning could be more sustainable and accurately aligned with actual demand growth. Implementing right sizing requires careful planning and orchestration beyond simply drawing rectangles and making recommendations. One tool to achieve this is auto-scaling. This is what I was thinking. It's often very difficult to figure out the right size. Well, you can if you have enough usage data, but even then, you'll need some auto-scaling to be provisioned because you never know when you have spikes. So I think the key here is doing auto-scaling. Auto-scaling dynamically adjusts resources to match demand. Initially, it's not so complicated to scale up when anticipating increased demand, ensuring sufficient resources. It is a safe move that most of us are happy to make. However, scaling down is equally crucial for sustainability, preventing over-provisioning and inefficient resource usage. Yeah, so we should definitely downscale as well as upscale. But I think this is mostly managed due to cloud budgets. If you keep up resources, then you need to pay for those. So it's part of the course that you need to downscale as well. So yeah, there are perhaps more complex, more sophisticated ways of doing auto-scaling that cloud providers still need to implement, but I think many companies already do downscaling. Mixed workloads. Imagine two workloads coexisting on the same system, differentiated perhaps by time or other factors. To achieve maximum utilization, you want the resources of these workloads to interlock or complement each other over time. For example, customers in different regions like Southeast Asia and Northern Europe may have staggered activity times. By scheduling their workloads to overlap less, you can optimize machine usage using more resources when one workload is less active and vice versa. This strategy requires tagging workloads with attributes for effective scheduling rather than relying on automatic processes. It's particularly effective for diverse patterns such as bursty, ticky sales versus steady update installs. Yeah, so that would be, that's interesting. Instead of doing downscaling, what you could do is to keep the resources tied up, but move workloads depending on the daily usage spikes, let's say. This would be an option. That's interesting. Another related concept is multi-tenancy, where different customer needs are combined to maximize machine efficiency. While challenging hyperscalers excel at this approach because it reduces the number of machines needed, thus enhancing energy proportionality and overall efficiency. One thing that I would like is for cloud providers to offer a graph of used energy. But if they do that, they will need to give some more information about their inner workings that I'm not sure they want to do. So yeah. Sustainability, cost, resilience. Sustainability shouldn't stand alone, but should interlock with other critical metrics such as cost. Increasing machine utilization often reduces cost, making it a dual benefit. You can prioritize cost savings and then consider sustainability benefits, or vice versa. Resiliency is another significant factor. Many green practices like auto-scaling improve software resilience by adapting to demand variability. Carbon awareness actions also serve to future-proof your software for a post-energy transition world where considerations like carbon caps and budgets may become commonplace. Establishing mechanisms now prepares your software for future regulatory and environmental challenges. Yeah, so I think the first two, so definitely true that you can reduce costs, and that's something you should look at in any organization, and I believe many already do. Resilience is also an interesting one. The thing with carbon caps and carbon budgets that may become commonplace, I don't want to go into politics, but as I see it today, there seems to be a backlash against these things. So it's not very obvious. And organizations will not necessarily move in this direction unless, at least that's my opinion, my personal opinion, they will mostly be moved by external factors. So I don't know. Maybe I'm too cynical, but that's how I think about these problems based on my experience. Well, moving to the cloud help. Not quite. While it can be beneficial, it's not simply a matter of lead time shift. There are vital considerations to keep in mind. One concept I want to highlight is light switch ops. Okay. It's about which Holly Cummins discussed the last year's QCon. It's about making it as easy to switch off resources as it is to turn off a light switch. Oh, nice. Just as we trust that the lights will switch on when we return to a room, we should trust that idle resources can be efficiently shut down and turned back on again, whether it's a server or network connection. Removing idle resources is cost-effective and greener, reducing unnecessary resource consumption and sending accurate signals to capacity planning. Additionally, there's serverless computing, leverages managed services like database and pre-optimized instances designed by the cloud provider. Okay, so serverless is a good way to go. What do cloud providers say? Okay, Google Cloud. Let's start with Google Cloud's approach to do their Google Cloud Architect Framework, which mirrors a well-architected framework. It's built on 5 pillars: operational excellence, security, privacy and compliance, reliability, cost optimizations, and performance optimization. Within this framework, they emphasize sustainability with 6 sectional strategies. First, understanding your carbon footprint. Google provides tools for location and market-based scope 2 emissions through location, though location-based is recommended for clarity and accuracy. On an organizational level, market-based numbers might also be interesting. Okay. So there is some data. It doesn't seem to be the most granular data that we would need, and I can understand why. It's quite difficult to separate energy usage per product, for example. Okay, next, location shifting. Google advocates for services like serverless options such as Cloud Run and Cloud Functions, which maximize resource efficiency through automatic scaling and efficient workload management. Google Kubernetes engines and BigQuery are also prominent due to their managed and serverless capabilities. They also encourage minimizing idle resources, and lastly, reduce emissions from batch workloads by optimizing scheduling to leverage greener energy sources. Okay. AWS, several key recommendations for incorporating sustainability, selecting regions with greener energy options to minimize environmental impacts, aligning resource provisioning with actual demand patterns, optimizing software and architecture. AWS encourages using managed services, right-sizing instances, and adopting serverless computing models like AWS Lambda to minimize resource waste and improve energy efficiency. Efficient data management, hardware instance types that have minimal environmental impact. For instance, AWS Graviton processors are highlighted for their efficiency in specific workloads, and Spot instances for cost-effective batch processing and time-sensitive workloads, and integrating sustainability into organizational culture. Okay. The offer seems to be there, but it's not enough. There seem to be missing a lot of things, right? It's just about switching workloads, optimizing. Okay, I understand. That's already quite good, but it's still not at the level where you could, for example, monitor your energy consumption per your product. That would be the best metric, and then seeing how much of it is green, but it's quite difficult to get there. So I guess we'll have to live with proxy indicators in the meantime and these solutions. Azure application design focuses on coding efficiently. Application platform consideration emphasize carbon awareness, right-sizing resources, eliminating idle resources, so same things. Testing strategies in CI/CD pipelines to ensure sustainable practices during software development and deployment phases, promoting automation and efficiency in testing processes. So that's interesting. This is the first time, and Azure is the one mentioning CI/CD pipelines, which is what I was talking about before. If you have your workloads for CI/CD in the cloud, the same things apply to them. So, yeah. Operational procedures encompass the measurement of carbon footprint, cultural changes, and operational practices that promote sustainability across organizational workflows and practices. Networks and connectivity consideration highlight strategies to minimize data transmission over networks and optimize data flow to and from applications to reduce energy consumptions and enhance efficiency. Storage practices discourage data hoarding, emphasizing the importance of storing only necessary data, minimize storage cost and energy consumption. And this is actually very good for security as well, if you only store the necessary data. Security recommendations integrate sustainability by designing secure architectures that minimize environmental impact, ensuring that security measure contributes to overall energy efficiency and resource optimization. Okay, this is a word salad. I understand, but honestly, it doesn't say anything. It's just that in order to be more sustainable, when you think about security, you should think about being more sustainable. It's not great advice, okay? This reminds me of the old the Microsoft style documentation that was always the marketing one was very circular. The development one, that was good. But really, the marketing documentation back when I was working with Microsoft technology, oh boy. So, and this is basically the same thing. Okay, so let's see the summary and then I will give you some conclusions. What should you take away from this article? Carbon-aware actions like demand shifting and shaping can help you be greener and future-proof your operation for a post-energy transition grid. Machine utilization is vital to carbon efficiency. You want appropriate machine utilization by removing idle resources and taking actions such as right sizing and auto scaling. Cloud can't help, but only with your actions. Think about using managed resources or the most efficient hardware. The software benefit from carbon efficiency, and building green is cheaper, more performant, more secure, and more resilient. All right. So let's see what we learned. We learned that we can optimize machines. We learned, I think the most important thing is that there are APIs that provide information about the greenness of the energy available at some point in time. And you can use those to schedule things. We could provide an eco mode for our applications. And we could schedule and shift and right size and downsize cloud workloads. And that's basically it. And my problem with this, it's okay. This is a good start. But the challenge is that you need to put this in line with all the other relevant architectural needs. So I'm thinking about security, reliability, performance, and all these other things. So question is, for example, are we okay with reducing performance in order to consume fewer resources in order to be greener? And this is the same trade-off that you make with your TV, right? If you choose the eco mode on your TV, it's likely that it will be, the brightness will go down. I don't know what happens with contrast and so on, but generally some things will go down. The image quality might not be as good, and maybe that's enough. Okay, you like it and so on, but maybe it's not enough. This is why I like the eco mode for applications, because it puts the user in charge and you can select I want the eco mode or I don't want the eco mode. I think at least that seems to be a good idea. And this also allows you to think about an eco mode and make these trade-offs, like let's say reduce performance by 10%, slightly increase the response time for certain services because we move to instance that is slightly underpowered than what we actually need, and it will reply in a longer time. Is that okay for your users? Well, they can choose, right? It's eco or non-eco mode. Now, of course, the challenge with this is that you can actually introduce your eco mode as an option for your users and not implement anything. Is not something that I advise you to do, but it's definitely what some organizations might do. And then you pick the eco mode, you're a happy user that you're saving reducing carbon emissions and all that. But in fact, nothing's different. This might happen as well, unfortunately. Okay, then about security. So when we talk about security, one of the reasons why they didn't go so deep into security is increased security necessarily will require more CPU cycles. Most measures for increasing security in code are about cryptography, so encrypting data at rest, encrypting data at transit, and additional checks, checking more things in your code. Checking that the user has a specific permission, checking that there's not some weird behavior of the user, checking a lot of different things. And if once you do that, you necessarily increase the energy consumption. So the trade-off between security and energy consumption is pretty difficult to make. It's already difficult to make the trade-off between security and performance, between security and usability. Now you add the third one, which is between security and carbon emissions, energy consumption, and so on. And this is one of the situations where, okay, if you have a workload that maybe does some things to data, and that's fine, you can shift that. But for the general work, let's assume you have a web application or a web service, tens of thousands of users or hundreds of thousands of users, you add an additional condition to improve their security. Yeah, there's no way around this. There's no way to avoid this. In this case, it might be a slightly higher energy consumption. The only way you can deal with this is by using languages that are more performant. Switch to Rust or C++. That on the operational side, they will be more performant. Now, another thing that I'm thinking about is one way that cloud companies could deal with that would be if they have hardware built for purpose, for a specific language. So imagine instead of running your Python code on software, the interpreter that translates into machine language or whatever, what you could have is a processor that already implements the Python interpreter. And that would speed up the whole process. how likely is this to happen? I have no idea. And the same thing can happen for Java, the same thing can happen for .NET or for other programming languages. It's likely less of an issue for C++ or Rust because they will optimize anyway the instructions and you can optimize a lot of things. But I don't think many people will switch to Rust or C++ for reducing emissions. And then there's another thing that we talked in another video. One of the interesting use cases for AI is actually to start, let's imagine you write your code in Python, you write tests that cover your whole code, of course. If you're doing test-driven development, you do it anyway. And then you switch to another, you use an LLM to translate the Python code into C, and you run the tests again. You make sure everything is working. You test manually, you do everything that you need to do, but you deploy the C version, which is likely more performant, more optimized. Is not 100% optimized, but it's probably, based on what I've heard, it might be 2, 3, 4 times faster or something like that. So even if it's 2 times faster, you reduce resource utilization by half, still good, right? So maybe that would be part of the answer. Or maybe part of the answer would be some kind of AI system that does this automatically and optimizes your code. And I guess some of it is already happening with compilers, virtual machines, all the different layers from software to hardware. So there are still a lot of challenges, and what I'm still missing is indicators that architects can look at, that operations can look at and say, okay, we need to improve that because that will improve our energy consumption, but it also points to something else, the reducing our costs or doing some stuff like that that benefits our organization. Okay. Overall, I think it's an interesting article. I think we need to discuss more about this. This is not a topic that will go away. It's not an urgent topic, I feel like. I think that it will take 2, 3, 4, maybe 5 years to get to the point where it's actually becoming something that many organizations pay attention to, or most of the organization pay attention to. But since it's an emerging topic and something that I believe will grow, I think it's worth paying attention to options in reducing energy consumption, which leads to cost reduction for your company as well. So what do you think about this? Have you been part of any sustainability initiatives regarding software development, regarding operations in your organization? And have they stopped at cloud, or is there more there? Let us know in the comments. And also let us know if you have any other questions related to this problem and how it fits in software architecture in general. Thank you kindly for the view, and until next time, remember to think, design, and work smart.